Hello, hello, hello. So, today I wanted to talk to you about what are RefLists in .NET, C Sharp, how they compare to your old plain lists. And since there's no support of RefList at all here, we're gonna have to implement our own, and I'm gonna talk about why would you ever want to implement your own RefLists. So let's jump into some code and let's see what's up. So if you're using a list in .NET, most of the time you're interested in having a data structure that expands inside. Because, for example, you don't know, let's just say that we have a class like here, transaction, and you don't know how many transactions to expect. You have no clue, so you're going to use the list because that's going to expand the backing array for you. So there's no need to you're not going to overflow. So there's no need to guess how many of the transactions are we going to have. And that's all good, that's all fine. This is a class, there's no problems here. So if we wanted to, for example, do stuff like, let's just say that we have a bunch of these transactions and we would like to actually calculate the total amount of these transactions. We're going to add an amount. That would be fine, right? There's no problems here, but let's just say that you're interested in performance, you care about data access patterns, because with a class like that, there's no telling where it's going to end up. And if you wanted to use data-oriented design, perhaps you want to stuff to go really, really fast, then what you could do here is actually use a struct to make the data layouts and data positions more predictable. So what happens now? Still, there is a for each loop that isn't a problem. Let's actually measure the performance of this solution. So I have here my super simple function to be able to measure a performance of something. It's just gonna call this and measure time. It's gonna do a quick warm-up where it's gonna call this multiple times to not have the cold start problem. But all in all, it's pretty simple and it gets the job done in this context. So we're gonna see how it performs. So let's actually start with the class to see what the problem is. So a class actually in this example took 52 milliseconds. And if we're gonna change it to a struct, it's gonna take 100 milliseconds. But if we're gonna add stuff to it, let's just say that date, not struct, string. Again, string, not struct. Get set. And let's actually add something else here, like the note. Perhaps we have a note here. Let's actually run it again as a struct, and as you can probably see, the performance down it's even slow, right? So it's gonna downgrade. And I don't know, another ID. So if we're gonna add to this, it's gonna get slower and slower and slower. And why is that? Let's actually verify if a class actually got slower. No, the class didn't actually get slow. The class is just fine. The struct is not. So what's the problem here? The problem is that each time we use this for each loop, it has something that we can call an enumerator. So it's just a simple data structure which has three things. So it will actually move our iterator, and it's going to give us the value. But if it's gonna probably create something like a local variable. Even if it doesn't, it will just give it to us, and then we're going to do some manipulation on it. And the problem here is that the compiler will actually do a defensive copy. So every time we're actually opening up this transaction here, we're getting a copy of the transaction. We're not actually manipulating the transaction that we have on this list. And that's a problem, because we're doing a lot of copies that we don't actually want to do. And the solution to that problem is to actually pass it by reference. But that list, at least from what I know, doesn't have any way of like creating this sort of by ref implementation. There are some ways, but they're pretty hacky in my opinion. So what we can do here is to implement like a simple RefList, which will have the exact same functionality as the list, but it's gonna actually go and create a ref enumerator. So let's actually try and do that. So let's create a class. Let's make it public class RefList of t. Let's create an array for it. Let's create an index for it, and let's create something that we can call capacity. And let's just set that to a default value for now. And let's actually create the ref list. And initialize our array using the capacity. Let's actually create another constructor which will not use any chaining, so a constructor will not call another constructor, and actually have the capacity here. Capacity, okay. So let's just say that this capacity equals capacity, and let's create an array using this capacity. And this actually this constructor actually allows us to say that we're kind of expecting a certain capacity. So in order to not like create small arrays and just copy them over from if they sort of overflow, we can have this constructor where we say, well, I'm kind of sure that it should be something around here, this value, but if it's not, then just expand anyway. Okay. So what else do we need in order to make this work? Well, we need an add method. So t value, right? So we have the add method, right? And now how to implement the simplest add method for now. So let's use the array, let's do index plus, and let's just say that it equals value. But we still need to expand it if we're going to overflow this array, right? So let's create a method called expand. And in this method, we're going to add implementation in a bit, but let's just do if our index is greater or equal to our capacity, then we need to expand. And how to implement the expand function? Well, pretty simply. So we have to say that the new capacity equals the old capacity times 2. So this is the simplest way how to expand an array. You just multiply by 2 and that's it. And now we have to create a new array. So let's do new array equals new of t with the new capacity. Right? And now what we need to do is we need to copy the array. So how do we copy the array? Well, we could use array copy. That's the simplest solution. It's not the fastest one, but it's going to get the job done. So what's the signature here? Source array, destination array, and length. So let's use our old array, let's use our new array, and let's actually say it's going to be array length. Now what we need to do is we need to assign these new capacities and arrays. So our old array equals our new array. and our capacity much rather equals new capacity, and that's it. Okay, so we have a very simple ref list. Let's actually add something else. Let's add an indexer because that actually helps a lot. So let's do public t this and index, and we have to implement a getter and a setter. So get, and then on get we're gonna return our array of the index, and on set we're gonna assign to an array of the index our new value, and that's it. That's pretty much it. Okay, so what we have here is a very simple implementation of the ref list, but that's not really complete because we're not passing anything by reference. But let's see if it actually works with the for each loop, right? Well, as it turns out, it doesn't, because in order for it to work in a for each loop, usually what you have to resort to is to have an enumerable interface, and we don't really have an interface like that because that signature is different. But the error actually tells us that we don't need an interface. What we just need is a method called getEnumerator, and that's very convenient because we don't have to implement an interface here for it to work. So this is one of the implicit tricks of the compiler, and I'm not a fan of it, but it's something that they had to resort to, obviously. And if you just have this magical method that has this specific signature, you're gonna add certain functionality just like that. So there's no explicit way to say that I'm gonna support a for each loop. It's only this method signature, but that's okay for now, because if that would be an interface, then we would have a problem, but now we don't. Okay, so what we need to do here is we have to implement something that's called getEnumerator, and that actually needs to simply return something. Let's actually do a stub now, so let's return new. Of course, it has to be public, and let's actually see if it works. No, because this is it doesn't implement a bunch of things because this is an object. So let's actually implement our enumerator. Let's just call it what would be the best name? RefEnumerator. And let's not string, struct. Let's create a constructor. Let's just pass our array. Let's do a capacity, but that's not our capacity, it's something different. And let's do end capacity. Here, let's create our array of t, and let's create an index for the enumerator. So the index is -1. So this array equals array, and this capacity equals capacity. And now what we have to do is we have to implement 3 methods. So it's getCurrent, moveNext, dispose, if I believe correctly, and reset. And since I don't remember these signatures, let's actually do a trick where we say that we're gonna implement a enumerator here. But we're not gonna do that actually. It's another trick because that has a very specific signature and we don't want to have that signature. Because what we want to do in the current is we want to return a ref. Not like that. And let's do a read-only ref. And here we're gonna do array of index, and let's just pass it in by ref. So now we're passing the struct via reference, so we shouldn't have that problem. Alright, so what we need to do is we need to implement these two. So reset is simple, so reset will just set the index to -1. And the move next, we have to just increment the index, and we have to also provide information if we can move to the next step. So what we can do here is we can pre-increment the index and just say that it has to be less than the capacity. And that's it. Now we can actually use this here, and what we can say is we can return new ref enumerator. Let's pass our array, but let's not pass our capacity because, like I said, this is different. Let's pass our index actually here. And now, hopefully, if I haven't like made any like off by one errors, it should just work. So let's test it out. It works. It's if I'm not mistaken, it takes the same time as the class version. Oh, I'm actually using the wrong list here, but still, the old like built-in list took around 130 milliseconds to 150. So it seems that it's working correctly. Okay, so hopefully you see that implementing like stuff like that isn't very hard. We just implemented a functional RefList. And now we can use this RefList with structs, and we can use the for each loop without like any problems. So what else is that we can do here to make this even more interesting? So let me show you some other like compiler magic, sort of say. So each time you have a list like that, you can normally, if you have a list, let's just say I'm going to have a list of ends. We have this initializer here. And to be able to have this sort of initializer, we have to have two things. We have to implement I enumerable, and we have to have a method with a specific signature again. This method is called add. And if we have these two things, then we can have this initializer. And all of the classes can actually have this initializer. It's not just that the list or something else. I've created in the past classes that have like wacky initializers for like different purposes. But again, I'm not a fan of this sort of approach because it's like, it looks like compiler magic. And, you know, I get that they had to resort to that, but you have to be careful when you're actually doing this sort of stuff. So let's try and do the same thing on our new constructed RefList. It's gonna crash because we have the signature of the add function here, but we don't have the I enumerable still. So let's actually implement the I enumerable. So since we have this, we only need this, and let's just say that for now we're gonna have a unimplemented exception. So what's the problem here? Oh, because we have transactions. So let's do a transaction, and it works. So we're not going to be able to pass this ref enumerator here because it doesn't implement this interface. So we could actually provide that, but again, we would have this ref problem. So actually, since this is like an implicit, explicit, so we have to have an interface to be able to call this. Then what we can do is we can actually do a couple of things, but for now, let's actually resort to the simplest thing. Let's just throw in an exception and just say that this interface shouldn't be used with RefLists because you're not going to have the functionality that you want to have. You have to use the concrete implementation here, and that would be it. Okay, so hopefully you liked it. You see the benefit of adding RefLists. And like I said, they're gonna be used every time you're trying to do interesting things on structs. And if you'd like to know more, why would you actually ever wanted to use structs? I have a lecture on data-oriented design, and that's not the only like case, why would you want to use structs? They're useful in a couple of things like concurrency, distributed systems, like I said, data-oriented design, and a couple of things. You can actually use them in a lot of places. You just have to be creative with it. Okay, so that's all for now. I hope you'd like it. And yeah, hopefully there's gonna be more interesting videos like that. So, okay, bye.